how it can be used in combination, concepts of chemical reactions and stoichiometry. And we're also going to be pulling in the gas laws. It's pretty much pulling it all together, which is really what we actually do in science. We don't do things in isolation. Let's do practice problems. So we have, and it says how many grams of zinc can react with 225 milliliters of a 0.2 molar solution. Now, we need to clarify a few things. It says 225 milliliters of a 0.2 molar solution. Which one is it talking about? Well, look at the context of the reaction. Zinc is a solid, hydrochloric acid, HCl, is a solution, it's aqueous. Look at those, the state of matter is very important. So we know that it has to be a solution, it can't be a solid. Now, but we have two solutions here. We have the hydrochloric acid and we have zinc chloride. So how do we know which it is? Well, it's speaking about what zinc is reacting with. So the context of the question tells us that it has to be referring to the other reactant that's reacting with zinc, or in other words, hydrochloric acid. So we have a volume given to us, we have the molarity, and we're trying to find the grams of zinc that would be necessary to react with that. We'll list these things. So we have the grams of zinc as the unknown. We have the molarity given to us of the HCl, which is 0.200 molar. And we have the volume in milliliters given to us, or we could say volume of HCl is 225 milliliters. Now the question is, which one should we start with when we set up our problem? We have two given values here. Which one should we start with? Well, it's easier to start with molarity because molarity, not molarity, the volume, and that's because molarity we're going to use as a conversion factor. Molarity can also be written as the number of moles per liter. Molarity is moles per liter. So this could also be expressed as 0.200 moles per every 1 liter. And that is a conversion factor which we will use to solve problems. Let's map out where we're going with this problem. So we are starting with the volume. We'll start with this one since it's not a ratio. It will be easier to start with that. We'll start with the volume in milliliters of the HCl. And we're trying to get to the grams of zinc. Now we have steps along the way. We have to go from one substance to another, and we have to change the type of unit. Now the central step in the middle, in order to go from HCl to grams of zinc, the central step is the mole ratio. So we know at some point here in the middle, we're going to need moles of HCl to moles of zinc. And once we go through that step, that is the part where we convert from one substance to another. So that's the center idea. We use the equation to compare those two things. So our goal here is to get milliliters converted to moles of HCl, and then once we have moles of HCl, we can convert to moles of zinc and then to grams of zinc. So to get milliliters to moles, we're going to use this, the molarity. Well, the molarity is moles per liter, so we will need to first convert it to liters of HCl. And then once we have liters of HCl, we can convert to moles of HCl. So in this step, we're using 1 liter equals 1,000 milliliter. It's a metric conversion. In this step, we're using the molarity. So that's this right here. And in this step, it's the mole factor or ratio. And in this last step, we can go from moles to grams of zinc by using the molar mass. So we'll look at the periodic table at the AMU numbers for zinc to do that. So let's start our problem off with the given value of milliliters of HCl. So we have 225 milliliters of HCl. And you got to say what it is when you do these problems. What it is. It's HCl. That's important to keep track of because we're going to switch from one compound to another in this step. So next is convert to liters. For every 1,000 milliliters of HCl, there's 1 liter of HCl. The next step is to convert to moles using the molarity. So use this as a conversion factor. For every 1 liter of HCl, there is 0.200 moles of HCl. Next step, mole to mole ratio. Look at the equation. For every 1 mole of zinc, there are 2 moles of HCl. So for every 2 moles HCl, there's 1 mole of zinc. And now that we're at moles of zinc, one more step, the molar mass of zinc to convert to grams. The molar mass of zinc is 65. So we have 65.39 grams of zinc for every 1 mole of zinc. Units all cancel, leaving us the grams of zinc as a unit. We can calculate, comes out to 1.47 grams of zinc. Let's try a second problem to this. So this problem says, given we have this equation, how many milliliters of a 0.33 molar Na sodium sulfate solution are needed to react with 26 milliliters of a 0.216 molar barium chloride solution? This problem is similar to the last one, except this time we are going from milliliters of one solution to milliliters of another solution. And so we can write down what we have in the equation. We are given the milliliters, or the unknown actually is the milliliters of the NaO sodium sulfate, Na2SO4. That's unknown. And we're given the molarity of that solution, however, as 0.330 molar. Now, on the other side, for the other substance, the barium chloride, the volume, or the number of milliliters, is given to us as 26.8 milliliters. And we have the molarity as 0.216 molar. So we can map this out. We are starting, like the last problem, with the volume of the barium chloride. So again, this is referring to, I should have wrote that here, this is all referring to BaCl2. So this is milliliters of BaCl2. And so we can map it out as starting with the volume, or milliliters, of BaCl2. And we need to find the milliliters of Na2SO4 that would react with that. So we know the central step is to go from moles of BaCl2 to moles of Na2SO4. So in order to do that, we're going to need the mole to mole ratio to compare these two substances. And in order to get there, though, we're going to need to use the molarity. Convert milliliters to moles and then from moles we can go back to volume or milliliters. Of course, we'll need to convert the milliliters to liters as well in order to plug into the molarity equation. So milliliters will be converted to liters, BaCl2, and then to moles, and then from moles we'll have to convert back to liters, and then we can convert to milliliters. Okay, so let's set this up, starting with the given value, this one right here, the one that's not a ratio, 26.8 milliliters of BaCl2. And in the interest of time here, go ahead and just show you a solution. So if you want to solve it on your own, do so. Pause the video. Here's what we're starting with. And so we have the 26 milliliters of BaCl2. And so the first conversion is use the metric conversion to convert to liters. That's what we're doing here. Then we use the molarity of BaCl2 to convert liters to moles, kind of like the last problem. Next is the mole ratio. It was a 1-to-1 mole ratio. And next we convert back to moles again, except this time using the molarity of the sodium sulfate solution. We have to flip the conversion factor in order to go from moles to liters. And last step, go from liters back to milliliters. Solve all that and we get 17.5 milliliters of the sodium sulfate solution. All right, we're going to look at another type of problem now, a variation on what we've done so far. So let's say that we have this equation. At standard temperature and pressure, STP, how many liters of NO2 gas are required to produce 0.275 liters of a 0.4 molar nitric acid solution? So in this case, we have some other things going on here. We're putting this all together. We're also bringing in the gas law ideas. So if we write down what we have the volume of a solution. So we have of HNO3, and that volume is 0.275 liters. And we have the molarity of NO3 is 0.000 molar, and that's right there. We want to know the liters of NO2 gas. So this is aqueous, and this is a gas. That's our unknown. And it's at standard temperature and pressure. So at standard temperature and pressure, 1 mole of a gas is equal to 22.4 liters. Now, one of the most confusing things for students is these are both liters, and the temptation is the same method we used in the last problem and use molarity to go back to liters. But this is liters of a gas, so we need to use gas law expressions. It's very important to read these questions very carefully and look at the equation carefully. The state of matter is essential.